Okay. Perfect. Okay.
So smooth.
So we got a clap before starting to speak.
Exactly.
It's amazing. It's the first time that happens. Okay. Okay, let's skip the presentation.
Okay.
I mean, we took these amazing portraits the other day, and they're now totally useless. Okay, now we can start with the serious stuff. So, we all heard about megapixels, right? Please nod. I really need you all to nod every time I say something.
At least the idea of
Okay.
megapixels.
So, what are megapixels? Well, basically, they are the resolution of an image. So, let's take, for instance, this image here. It has a size of 6,000 pixels by 4,000 pixels. So, to get the, thanks, Francesco, I really love you. To get the megapixel, you simply multiply one by the other, and you get to 24 megapixels. Okay, why this is important? Well, it's important because we often refer to megapixels as the small little dots that you can clearly not see inside the sensor of the camera. But this is not 100% correct. Because those little bodies there are called photosites. I mean, I hope the pronunciation is correct. I literally learned the other day, because I call them megapixels as well. But we call them in this way for a reason, because we usually map one of these photosites to a single pixel in our image. We usually do that. So, what is the difference between this thing here and this other thing here? Apart from the operating system that Chet today told us why on camera we have this mess, we'll be complaining a lot about that, don't worry. Well, the size of these photosites is different. On cameras, you can have photosites that are as big as 8.4 micrometers per side. They are squares. Each side is 8.4 micrometers. On phones, they are slightly smaller. Well, not quite. They are quite smaller. They go from 0.8 to 2.44, which is a lot. So, how does this work on phones, especially? Well, a lot of phones nowadays ship with 100 megapixels. Now, we are not getting poster-sized images, but they need to do that to give us a better quality. So imagine that this is a real size photosite that how less than 1 micrometers look like. So this is the size of each of the small little dots inside the sensor of any of your cameras in the back of the phone. But what happens nowadays is that they don't really give you 100 megapixel of picture because they tend to group these pixels so that they can get more light. Okay, this sounds confusing, right? So, this is something that you might have heard about the superpixel or the pixel binning. Basically, instead of taking one single photosite, you take more of them and you group them together so that you can get more light. Okay? The concept here is that you get more light. This is the important part. Okay. This technique is also known as pixel binning. At least I believe so. Wikipedia told me so.
It should be.
Not sure. Okay, thanks. So, let's take an example, a real-life example. So we have here a Samsung device which shipped with a 108 megapixel camera. But, well, if you take a normal camera and shoot a 108 megapixel picture, you can literally print it at native resolution and cover a building with that. That would be the size that it would be if you could ever print it. So what does the Samsung sensor do is basically group each photosite with other 8 that are closer to him so that it ends up having a real sensor of 12 megapixels. So instead of having a huge image, you have a smaller image, basically. Okay? But this which is moving the sensor slightly by a fraction of a pixel in a direction or the other to gather more details. I don't really know how they do that, honestly. There are some cameras that mechanically move it, but I see that more on like real cameras than on phones. But this is the general idea. So, all this introduction was actually leading to a totally different concept, which is the fact that megapixels are really complicated to deal with. Because if we take another real-life example from cameras, we get two very high-end cameras, those that I wouldn't be allowed to use for many reasons. First one is that I will drop it the moment I use it. I mean, you saw what happened with my laptop. But those two cameras are really different, and they've been released months apart. So it's not generational changes. So they brought full-frame cameras, but they have very different sensors. One ships with a 61 megapixel sensor, and the other one with a 12.1 megapixel sensor. Okay? Remember, they are both high-end cameras. They're not an entry level and an high-end. So the difference is that the one on the right, while it has many more megapixels, has photo sites that are really smaller. And the other one are, well, probably the biggest photo sites that you can have in full-frame cameras. So why is that? Well, with one, you can have much more details because you have many more pixels. In the other, you have less noise.
So basically, the image having less noise is more defined, is less grainy, let's say, because you have just the interesting signal in the final image. You don't have the noise exactly, which is basically wrong signal, wrong information saved in the final image. So it's pretty important to have a big sensor, even if you don't have a lot of megapixels, but in this case, the purpose of this camera is to have better quality in different light conditions. While for the other one, having such a huge resolution is more useful for other purposes, for example, for landscapes, where you could have a lot of details even in a far subject away.
Okay, thanks.
Yeah.
Okay. So, why are we talking about this stuff? I'm not telling you right now. You have to deal with that a little bit more. But trust me, it's important, probably. So, as we mentioned earlier, well, with a bigger sensor, you get more light. Again, more light is really, really, really important. Because the more light you get, well, the better picture you're going to take. So all the pixel binning stuff and having less megapixel on the camera is just to get more light. Because if you get more light, well, your pictures are going to look much, much, much better. Okay, now there is another little brick that we need to add before we can dive into why we're doing all this stuff. And, well, this is the crop factor. So, historically, we refer to the 35 millimeters film, which was the real dimension of the film, as the standard. So every dimension in photography is actually compared to that standard. Every other sensor will basically be a scale down or scale up of this specific sensor, and it will have the same ratio, which is 3 to 2. How do you say that in English? Yeah. Well, 3, 2. Sorry, I don't know how to say that in English. I will learn at some point. And for instance, the camera that we have here for the demo is an APS-C camera, which is a 1.5 crop factor. This is important because later we're going to see with what happens with smartphones basically, what happens is that you take the center part of an image when you crop from the full frame. So when they have the same size, it looks like you zoomed in, but in reality, it's just that you really could see only a part of what a full-frame camera could see.
This is if you are using the same lens.
Yeah.
So using the same lens in different cameras, but with a smaller sensor, basically you are losing the outside part of it.
Okay, so this comes another piece, which is the focal length, which is more or less the distance that your lens has from a very specific point between the lens and the sensor on your camera. Don't really remember the exact name, but it's a distance that calculates really precisely on a full-frame camera. So whenever you see a lens on any other camera, remember that you have to apply some math to understand how it really performs. So, when, for instance, you have a smaller sensor and you read a number, you have to multiply it by its crop factor, and that comes again the zoom in, because your real length will be longer, and the longer it is, the closer you are to the subject. So we have already two factors that compete in giving you the idea of zoom in when you have a smaller sensor. And the same applies to aperture, which is what defines what is in focus and what is out of focus in your photos, okay? So, for instance, on my phone, I have a Samsung Galaxy S20 FE. We have 3 cameras. We take only one, for example. So the sensor size is much, 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 much smaller than what we have on a normal camera. It's 7.5 millimeters by 5.44. The declared aperture is 1.8, which is incredibly open. I mean, if you take any full-frame camera and try to take a picture at 1.8, you will see that probably only the tip of the nose of the person that you are trying to photograph is in focus. The rest will be totally blurred. Well, not totally, but mostly blurred, okay? And its declared focal length is of 26 millimeter. But these are the data that are compared to the full frame. Because if you apply the crop factor, you see that actually you have a much closer aperture, which is of f8. To give you, again, an example, if you take a picture of someone at f8, you probably not only see them in focus, but also the people behind them and behind them and behind them. So the exact opposite of what you would get, what would you would want. And the real focal length is only of 5.4 millimeter, which is incredibly wide because, again, it really needs to grab more light as possible. Okay, unfortunately, on phones, we can't really change the aperture because many of these lenses come with a fixed aperture and a fixed focal length. But luckily, on cameras, we can actually change that. So when you have a camera, that little f1.8 is the aperture, which again tells you what is in focus and how much of your scene will be in focus and how much will not. So, what about phones? Because after all, we are here to talk about phones. Not really, not this time. So, again, we take the same device as an example. We have the primary camera, which is a 12 megapixel with an aperture of f1.8, 26 millimeter. A telephoto lens, which is an 8 megapixel f2.4, 76 millimeter. And the wide angle, which is a 12 megapixel f2.2, 13 megapixel. So, with all we've seen now, we will think, why there is no shallow depth of field? Well, again, for the crop factor. because applying everything, we know that these values are really slightly different on the phone. But now we'll show you an example.
Yeah, so to make it real easy to understand, let's see some example with some pictures that we took the other day, using different cameras and so different sensors. On my camera, that is a full frame one, you can see that here, the subject, which is this mini figurine, is clearly in focus, but the background, it's pretty blurred. I mean, maybe you can guess where we were, but it's totally blurred. With this camera, which has a cropped sensor, again, subject is in focus, but the background is slightly less blurred. It was taken with the same lens, well, equivalent focal length, because we said before, different sensor, so slightly different focal length, but same aperture and same distance from the subject. If we took the same picture with a phone, then you can see that, okay, clearly you can understand where we were, what is the background, but again, the focal length was the same. The only thing that, and as well the aperture, the only thing that changed in these three pictures was just the sensor. So as you can see here, the possibilities that a real proper dedicated camera has compared to a smartphone is way more. There are some just physical limitations that, of course, they can be adjusted or overcome with software, but those are just workarounds. The actual real blurred effect that you can achieve cannot be comparable just because of the size of the sensor and physics, I guess.
Yeah. So another thing to remember is that we now compared cameras and phones, but they all serve the same purpose. So whatever camera you have with you, that's fine, because the only camera that you're going to use is the one that you have. So it's fine. OK.
I mean, of course, yeah, okay, the camera that you always have with you, your smartphone is definitely more accessible. Our cameras, they are not exactly something that you can have every time with you. They are bulky, they are heavy, but they have their advantages, as we just saw. But what if we can use the power of one to control the other? It would be great exactly to have some way to control our camera through a smartphone app. And there are some features that we would like to have. For example, of course, the basic one is to be able to remotely control the camera, so we can avoid vibrations if it's on a tripod. We can actually be in the frame if we want to place the camera in some nice spot and be actually able to be captured as well with the picture. We might want to be able to also control and to have some sequence of programmed shots for different kind of light situations. And why not? Given the UI in most of the cameras in the screen is really bad, the menus of most of the cameras, they are really bad. It would be nice to have a pleasant UI to work with for once. Most of the available remote-controlled apps, they offer, well, for sure, remote control and some kind of capability to do long exposures, but most of the time they lack advanced settings or most of the time good UI. One big example is the Sony official remote control app, which, as you can see, it has a pretty basic UI. It allows you to do what you need to do. It's basically just a wireless remote for your camera. You can set the shot configuration, some parameters. You can see and download some of the some of the previous pictures, but there's not much more than that. There are, of course, third-party alternatives, like the Shutter one, for example, is a really good one with nice UI, a lot of advanced features, wearable support, but unfortunately it's only for iOS. So no luck for us that we are Android users. Others, for example, like Monitor Plus, they offer a lot of advanced features in the paid Pro version, of course, but only works with some of the newest cameras. And with some of the others, like the ones that we had, this app only works when it's wired connected. So it doesn't have wireless support, which lost a bit of the purpose, honestly. So at this point,
It also only works on landscape.
Yeah, true.
Which is
Also that.
okay.
That's also a big limitation. So we decided, why not make our own?
Which is the real topic now.
Exactly. Finally, 20 minutes
Finally,
in,
after-
we managed to
Yeah.
to
20
arrive
minutes
here.
in, that's fine.
So luckily, we were lucky enough to have an SDK available from Sony. Well, lucky-ish. Because
Sony is the only one providing one, so
yeah,
I mean,
this
they're
already,
the best by definition.
it's already something, yes. But the problem is that Sony provides actually 2 SDKs, but we are not double the luck. The problem is that one SDK is only available for the newest cameras, like the one released in the last 3 years or so. Last year? Oh, yeah.
Last year.
Okay. For our apps, the only one available is an SDK which is in beta, and it was last updated in 2017, I think. So, yeah.
Wait, it went all the way from beta to deprecated
True.
without any release in the middle.
Yeah, true. It's also deprecated now. Yeah. And we'll try to, we will show you how it works a bit, and you will see why it is so bad. First of all, let's see how the phone can connect to the camera. So when you enable the remote control feature on the camera, it basically creates a wireless access point. And on the display of the camera, you can see the SSID and the password for the network, as well for a QR code, and also support for NFC to quickly connect the phone and the camera. Once the phone is in the same network that the camera created, it uses SSDP, which is a network protocol for advertising and discovering services on the network, in order to get the entry point for a REST server that is exposed by the camera. And after that, everything happens basically using REST APIs. We will see later that the problem is that these REST API, they are using very weird formats, and they are really, really difficult to debug.
Yeah. To give you an insight, I mean, we are all Android developers, and we are used to have, I don't know, many deserialization engines, like JSON or Moshi or Kotlin serialization. Yeah, forget those. You have to do everything manually, because that's how it works. That's one of the nice things about this.
Yeah. So basically, there is just one single endpoint, and you need to pass a different JSON payload, and you will receive a totally different format of JSON payload depending on the method that you are calling in the same endpoint.
Yeah, so it also depends on what the camera wants to give you.
And the camera model, of course.
Yeah,
the camera model, So let's start to see a bit of example. For example, let's see how the camera is set at the moment and how we can update the app. Something to remember and to consider is that the camera, the physical camera, needs to be the only source of truth, because of a simple reason. The camera has controls, like physical controls that the user can change. The user can, for example, change the shooting mode, the exposition compensation, or depending on the status, they can change the time or the aperture. And our application needs to reflect that. The app needs to be reactive and updated when the user does something in the physical world. So how we do that? This is a good example of why this SDK is not that great. So how we get it is to send a request with the method getEvent, and as a response, we will receive the actual status of the camera. The first time we will receive basically everything, so the status, the available APIs, the current configuration, current shot settings, etc. As soon as we receive a response, the app doesn't do anything, and the camera doesn't do anything else. If you want to be updated, we need to send another getEvent request, and at that point, only if the user does something in the camera, for example, changing the exposition, then we will receive another response from the server saying, hey, something has changed in the camera, you should update the UI. So this is the new current value. Of course, it can happen that when we request an update from the camera, nothing happens, because maybe the camera was just there on the table, and the timeout exception happens. And here, the official solution to do that is just do another request, because that's how you should deal with that. Of course, the app should not be just a mirror of the screen of the display of the camera. We should also be able to configure it for a shot. So of course, there are other methods for setting the speed, for example, the sensibility, the aperture, etc., and other parameters. Of course, when I say another method, remember, is the same API, same endpoint, just a different JSON and totally different formats of parameters that you need to send.
Yeah, you simply just pass another parameters, and the response changes structure.
Yeah.
It's so nice. It's really nice to work with this.
So while basically all the communication between camera and smartphone happens with the method that I described, so different JSON, just one different thing that we need to do is to display the actual live view of what the camera is seeing, let's say. In this case, we need to send, yet another method, which is start live view. But as a response, the camera is going to send a local URL from this local network. And once we receive it in the app, we need to create a socket, open a socket to that URL, and start reading a byte stream, which is basically a stream of bytes, which, yeah, exactly, they represent every single frame of the live view. And basically, our app needs to cut the right amount of bytes to display every single image, one after the other.
Yeah, and also it's not instantaneous. Like if you move your camera, you see it lagging. But that's not us. It's every app that works like that.
If you imagine, we'll show a demo later to see that it's not that great.
Let's see if everything works. I mean, we really got into that.
Yeah. Okay.
Oh yeah, it's up to me now. Okay, now let's talk about how you can actually take a picture. So you know that you basically take a camera, point it, and shoot. Yeah, it doesn't really work like that. There is a bunch of magic involved. So you may want to upload your shot data. So again, aperture, ISO, shutter speed, and that's okay. Then, well, you have to actually half press the shutter. Because so the camera, not by hand, but there is a method that actually half press the shutter. It does that.
You need to fake the action of focusing, which you do half pressing the center.
But remember, the focus is not instantaneous. It takes a few milliseconds. So you have to add a delay, because otherwise, basically, nothing afterwards is going to be executed.
Here, it would be great to receive a live update when the focus finishes.
Yeah, no.
But meaning live update, you need to send another get event, get event, get event until the focus finishes.
That's a continuous polling. You know that the push notification? Yeah, no, no. So at that point, you finally are able to take a picture.
Yay.
But not quite. Because then you have to await to take the picture. And then, since we all use coroutines, you know, when await comes back, I will have my response. More or less, it might actually come from the await take picture or from yet another get event. At this point, you finally have the picture URL, which is in the same format that we saw for the live stream. And fun fact, well, we wanted to show you a demo of this, and we managed to probably have it working 1 hour before the talk. Probably, not sure. We'll see later.
Excellent. Let's see if we can show you something. So, yeah, this idea of ours is still a work in progress, but we will show you something later, hopefully, with the demo. We have a lot of ideas for the future. So, of course, adding more features to the app, because at the moment it's pretty basic, but we really want to experiment with some technique that involves different shots. So having a pre-programmed series of shots with different characteristics, different settings, expositions, etc. An intervalometer for time lapses, why not? Or astronomical photography. Of course, we are still not able to transfer images from the camera, but that's planned. Wearable support. I mean, somebody still uses wearable. I would love to use them as a remote control for my camera, honestly. And finally, something that we really want to is to open source an SDK to allow other developers to have a better life when developing a camera app, or at least a camera control app for Sony cameras, or maybe for others, who knows?
Yeah. If you want on board on this project, just ask us, and we need a lot of help. Don't worry, a lot. Seb actually can tell that. Okay, so
Cool.
Well, before the questions, where we actually will choose some winners because we have some prizes. We have 2 books from Ray Wenderlich and 3 months license to IntelliJ Ultimate for 3 months, right? Yeah. Okay, but before the questions, we're gonna try to do a demo.
Let's try.
Again, today the odds are against us, but you never know. I'm a little bit afraid of touching everything. Can you do it? Yes.
Questo.
Mhm.
Ok.
Just. Aspetta che.
È accesa?
Sì, accesa.
Yeah, sure.
Okay. Well.
One second. Okay. Yay.
Yep. Oh wait, they cannot see the camera.
Well, but we can just already show the.
But they cannot see the app.
Ah, okay. Yes.
Yeah.
Now they can.
Okay. So as you see, the connection is really, really fast. I mean, Daniele pressed like 3 seconds ago. Of course, it's not working. Really?
Yes, exactly. It's a demo effect.
I told you we should have used the video. Would have worked.
Oh, wait.
Okay, let's try again. The camera is switched on, so it's not my fault this time. Does it work?
Is it connected to the real? Yes.
It's connected to the real Wi-Fi.
No.
Well, worst case scenario, we'll show the code so they know that
Exactly.
it actually works.
Okay, connect.
And you want to try it with your gear?
No.
Oh,
here it
okay,
is.
yeah. Woohoo! Okay, so give it a moment. It will also show the live preview. Probably. Well, no, don't worry. That's just the background of the live view. Yeah.
You see?
I mean, at this point, I'm worried of pressing any button. Yeah, it works. It works. It works.
Exactly.
Okay. So now the only thing is to take a selfie.
Exactly.
Please watch me because I'm gonna fall.
Oh.
Don't make me fall, please. Okay, Danny, I can't see you in the picture. Danny, you're not in the picture. Okay.
And 3, 2, 1, cheers.
I don't have that working.
Oh no, you put that.
I didn't put anything.
Okay. I thought you still had the self-timer. But yeah,
Probably
it worked.
yes. No, that's just frozen.
Shh, come on, they didn't know that.
Yeah, now
here it
it
is.
worked.
So you see how fast it is to connect and to transfer stuff over this Wi-Fi. So,
Yep.
well, kind
But
of
it
worked.
Yeah, I mean, that's...
Okay.
Okay, now we have
now
time
if
for
you have
questions.
if you have a couple of questions.
You can ask anything, also related to the code. We might be able to show it. It really depends on the computer, though.
Did you look at the newer SDK? You said there are two.
Yeah, the problem is that it... No, it's actually much better. The problem is that it has hard-coded the model of the cameras. So unless you find a way to change the model inside your camera, it's not going to connect. So,
Or, unless you change your camera with a
Yeah.
new one,
yeah. Okay. Other questions? Not even clear? Yes, we probably can. Definitely too many notifications. You see, tracker comes in handy. Yeah, those are not the errors from the camera, definitely. So let's find one that didn't fail. So as you see, well, probably you can't see, but I'll try. Okay, so this is the payload that we send. Here there is the method, which is getEvent, and then there are a couple of other parameters. I don't remember what false means. Probably give me just the update thing.
exactly, it's just the update, yeah.
And then there is the version. As you see, this is what we get from the camera.
Okay.
And it really is not null. It's really an empty string. But probably Daniele can find one that has something.
Yeah, exactly, maybe.
Yep.
Oh, maybe we are not logging them.
It's a
That's the
really
thing.
reliable API, really. Yeah, a lot of time.
Yes.
Because it's complicated because based on the camera model, the same method will actually behave differently.
Yeah.
Like the first 2 to 3 weeks, we were trying with 4 different cameras. There was mine, Daniele's, and Sebastiano's, which all have different models.
Actually.
And we couldn't really find an algorithm that would make them all connect. Because also the connection is really complicated, not only from the camera, but also from the Android standpoint. Because as you saw, from probably Android 10, you need to connect specifically to that network. And we went probably low level to the socket and all this stuff. And I'm not really sure how that worked. And I'm the one that coded that. So, okay. So, yeah, I probably can share a log cut afterwards because it's not helping now. I can't hear anything, honestly. Can you come closer or raise your voice? Okay.
So the responses you will get from a connection with a kitchen appliances would depend directly on the manufacturer.
Of course.
They have the most, very performance.
Yeah, but at least in that case, you had different manufacturers. In this one, we have just one manufacturer, but they couldn't have a consistent API for different models. So it's like.
But at least you understand our pain.
Yeah.
It's painful. Yeah, Chet, you have a question? Yeah.
Yeah, so you said manufacturers, this is specific to Sony? Are there also APIs for Canon and
This is specific for Sony because it's the only one that provides an easy-to-access SDK. For instance, if you want to use the Fujifilm SDK, you need to actually ask them for permission. If they ever approve you, you're going to pay a license to download the SDK. For Nikon, it's totally closed. I mean, you could probably find a way to deal with that, but there's no way. And Canon, I have no idea. I didn't check. Yep.
Do you still want to build a camera app?
Oh, yeah, of course.
It's a
Of
challenge
course.
now.
I mean, the real goal was to show that we have a reason to build this app, because otherwise the first 20 minutes, that's why the first 20 minutes were there.
do you think it would be cheaper just to buy one of the new ones?
Yeah. It depends. Depends. I only have 2 kidneys, so probably not. But
It sounds like your plan is to build an open source library for cameras. Have you considered phones instead?
yes. Yes, but they have an expiration date, and they take quite a lot of time to develop my picture, so I was kind of scared.
Would you ever consider creating your own
Oh, wow.
Yeah. Well, there are actually a lot of Kickstarter projects that do that with people that are way smarter than I am. So probably no. So I'll tell you one thing. Everything that is software, I probably can slightly understand. If I touch anything else, yeah, I'm going to burn it. That's a given. He knows it. I mean, I burned a lot of things. Yeah.
Have you looked into profiling reverse engineering other apps to see quite how they may be different, especially for the other manufacturers that are a bit more cumbersome?
Well, we tried to see what the Sony app does, because they also released an open source sample. And yeah, no, that's the same thing. The only thing that they do differently, which we didn't do here because, again, we completed the demo 1 hour before the talk, is keep on retrying. So every time they get an exception or an error or something they don't expect, they just restart it, which looks a bit, yeah.
You just touched on that very briefly, but I wanted to ask you, how much did you enjoy the service discovery part of that process?
Oh,
If only there was a talk about that.
yeah. So I'm passionate about these kind of things. I mean, I love ZeroConf. I'm probably the only person on the planet. I have to say that this time it was really painful because there was nothing on the internet. It looks like I was the only one with this problem, not even on Stack Overflow. Imagine that you have a problem and nobody wrote on that on Stack Overflow. So I really went by trial and error. At some point it worked, but just on my camera. Not on yours. Yep, I remember. I remember the back and forth between your changes and my changes, and nothing never working. But that's fun. It's all the fun I need. Yep.
What's your thinking or your opinion on manufacturers making API access easier in the future?
Yeah. So when this morning Chet told about the fact that they wanted to go for camera, I really wished, oh yeah, if only they did that.
Yep.
Because apart from the fact that we are Android developers and we are used to Android, I think that having a single system, at least for communicating with your camera, will make all our lives much easier. I mean, it's clear that most of these companies don't have the time to properly create apps that are easy to use. I mean, I would love an app that is as easy to use as my phone camera. I don't care about anything else. Just want to slide the things, and that's it. So if we got some sort of API for that, I would be super happy. Yeah, that's what we try to do, but
Yes.
I mean, it's not been super successful so far. We try. Yeah.
Do you think it's ever going to be performant judging on the SDK you have, or do you think it's always just going to be clunky?
Yeah, no. I think that's the best we're gonna get at some point. I mean, some point we're gonna tweak it, but
Yeah, but to be fair, even with the official app or other third-party app, they are not faster than this.
I mean, it's a huge amount of data that they're shipping over this wireless,
yes.
right? So I'm not surprised that it's slow. That doesn't seem a problem with their API.
No, exactly.
Just the amount of data in these huge pictures.
Yeah, probably I would have designed them in a slightly different way so that it was also easier. I mean, after all, you need a constant connection, so why need the phone to poll continuously? It doesn't really make sense as of 2021. Probably not even at 2020
Exactly,
or
yeah.
2000. So
Did you try with a wired connection on camera? Does it change much like the reliability of the API?
I didn't try, was scared after trying with Wi-Fi. So connecting a cable was the last thing I wanted to do.
I don't remember. Is for this version of the SDK, is there a wired possibility?
Nope.
It's only
There
wireless,
is-
right?
Well, at least it's not in the documentation. So, the documentation is shipped as a PDF.
Yes.
Not joking, like there is a PDF that tells you the responses of every single API you can call.
Actually, I wonder if there is a wired possibility, because they have a desktop app that connects to that camera.
Yeah,
But that's the new one. I think.
No, also for
It's for the old one.
But also monitor works only with wired. I think that somehow they share the same request. Probably
Hopefully.
that's why they created it in this way. Yeah,
Yes.
it is really bad.
Have you tried and seen if there's any difference in performance and reliability with the first-party applications between the Android versions and the iOS versions? Is it a completely different experience, or is it the same? Like, is it bad both ways, or is it just worse on Android, worse on iOS?
Well, we know for Android, and we have a teammate that actually has an iPhone that will do that right after this conference.
No, actually,
willingly or
no, actually,
not.
I tried the iOS one, like the official Sony one, and the performance, they were not better. So,
I wanted to make him do it.
well, you can.
Another teammate that has an iPhone.
True. True.
Okay.
Well, thanks everybody.
Yeah, we still we still have to select the winners.
True.
Yep. Can everyone that asked the question raise their hand, because I totally forgot who asked the
Yeah,
questions.
exactly. Too many.
Okay.
More than exactly.
1, 2, 3, 4, 5, 6. It's 6. Count you as well? Count you as well, because I don't
Yeah,
sure
yeah,
I see
six.
everyone. Okay, so we have 5 prizes though.
I think that Seb can provide another license.
Yep,
Okay,
we have 6 prizes.
Perfect.
Okay, now we only have to choose who gets the books.
Okay, so which
Can we make a random thing? Because we didn't really think about it. I mean, I usually don't get questions, so
No,
I
exactly.
wasn't prepared to this last part.
Not so many.
Okay, so
Okay, let's do. Who really wants to learn something about Dagger? Okay, you want it?
okay,
Who
come
wants-
to me afterwards and give me your email afterwards. Okay, now we have, totally forgot, Jetpack Compose, something that we didn't totally heard about today. You got it.
One.
Perfect. For the others, we have 3 months of IntelliJ Ultimate available for the other 4. And thanks all for being here
Yeah, thank you very much.
at this time. Thank you.